So another question we were given, answer the whole of this question on a sheet of graph paper. The table shows values for the graph of y is equal to x cubed. So that in this case, you're actually given all values. There's no need for us to calculate anything on this part. Simply draw the graph straight. So A, using a scale of 2 centimeters to represent 1 unit on the what? X-axis. And 2 centimeters to represent 5 units on the y-axis. All right? For each and every 2 centimeters, gonna represent 5 units. Draw the graph of what? Y is equal to x cubed. 4 minus 3 up to, okay? Minus 3 up to 3. So that is 2 centimeters, 1 unit. Let us try to readjust here so that all values can be accommodated. We can just have it in within here. And for the y values, okay, sorry for that. So this one, okay. Then we're going to take this one for the y values. Okay. This does not want to move. I don't know why. Okay, something like that. So let's hope this is not gonna affect anything, guys. All right, so let's say your Cartesian plane is like this. So you're going to indicate these values from minus 3 up to 4. 1, 2, 3. Okay, it's gonna work. 1, 2, 3, 4. Okay. Then minus 1, minus 2, minus 3. Okay. So the y-axis, they're saying every 2 centimeters represent what? 5 units. So it's going to stretch a little bit here. This one, 2 centimeters represent 5 units. So it's like minus 5, minus 10, minus 15. And what are we gonna need, guys? Those values, they're gonna affect, even if we're gonna take it there, 5, 10, 15, 20, 25. Okay, so minus 20, minus 25. Let's hope I'm gonna win. Guys, let's hope I'm gonna win. Okay, so this is negative 20, negative 25. Okay, no problem. And we do not have 30, so it's not a problem. So that is going to be 5, 10, 15, okay, 20, 25, okay, 30. All right, so exactly what I needed. So it's going to work. All right, no problem, no problem. Let's see. So meaning to say here you must understand the scale on the y-axis. 2 centimeters represent 5 units. So meaning say 2 boxes will represent 1 unit, like minus 1, minus 2, minus 3, minus 4. So 2 boxes actually represent a unit, 2 boxes, all right? So let's mark our points. That's negative 3, 20, negative 3, negative 27, negative 3, negative 27. So that's negative 27 after 25, 2 boxes, remember, it's 1 unit. So this is negative 26, negative 27. All right, so we can accommodate that. So that's negative 3, and negative 27. Okay, somewhere here, this one. So that's it, negative 2, negative 8. Negative 2 and negative 8. So this is negative 10, negative 9, negative 8. 2 boxes, 2 boxes. So 2, 4. 4 boxes from minus 10. All right. Or simply take from minus 5. So it's minus 6, minus 7, minus 8. Okay. So that's 2 minus 8. And another one, minus 1 versus minus 1. So minus 1 and minus 1, 2 boxes going down. This is it. The other one was 0 versus 0. This one, they're just positive. 1 versus 1, 2 boxes again. 2 versus 8, this is 5, 6, 7, 8. So this is 2 versus 8. And the other one, 3 versus what? 27. This is 25 here. So that's 26, 26, 27. It's going to be somewhere here. You mark that point. So after 2 boxes, it's 1 unit. So this is 20, 21, 22, 23, 24, 25. All right. 2 boxes. After 2 boxes, 2 boxes, 2 boxes, like that. So you count 2 boxes like this: 21, 22, 23, 24, 25. So here it's 25, 26, 27. All right. 2 boxes are representing 1 unit on the y-axis. So with these points, you're going to simply join them and have your cubic function. So that's a cubic function, remember? So something like this. Something like this. Something like this. All right. Here we're going up. We're going up. Okay. Sorry for that. So guys, it's just gonna be a little bit something else because of the scale. They separated too much these points, guys. They separated. They were supposed to use even they're supposed to use 2 centimeters to represent 10 units. At least that one, the points were going to be closer. This one, they're so separate. But anyways, if you're given something like this in exam, you just have to follow what you're given. So you're going to have something like this. All right, that is it. Your cubic function is stretched as like that. Y is equal to x cubed. Okay, so from the cubic function that we have just drawn, we are supposed to answer these questions. B, use your graph to find item 1, the gradient of the curve at x is equal to what? 1. Where x is 1, we need the gradient. So where x is 1, remember the gradient, we must have a suitable tangent. So where x is 1 to the graph, we have the point already. So it was going to be 1 here. We have our tangent. Okay. Something like this. Okay. And the tangent was supposed to be like this. So using a ruler, you won't find it difficult to have this line, guys, using a ruler, because the ruler, you can move the ruler from outside to the graph. So it automatically have that line straight, all right? So the point of tangents, remember our point of tangents, this one, it's 1, and we have it from our table of values. 1 corresponds to 1. So we already have the point of what? The point of tangents in this case. So that's at what? 1 versus 1. And we need the second point, which lies on the what? On the straight line, this one. So we can use this one, 2 corresponding to this point. That's 4, just below 5, 2 boxes below 5 here. So this is what? 4. So you can use the point 2, 4. Okay? So that is basically what you're going to have. So with these 2 points, our gradient can be calculated, as we do understand gradient is the change in y over what? Over the change in x. So that's it. Y2, that's 4, minus y1, which is 1, over x2, which is 2, minus x1, which is 1. So this was going to give us 3 over 1, which is what? Which is 3. So our gradient in this case was going to be equal to 3. Okay? Then another one, you're being asked about the area. Item 3, the area enclosed between the graph, all right, and the line y is equal to 2x. So we must have the curve and also the line of y is equal to 2x. This one is a straight line. So let's draw that line first of y is equal to what? Y is equal to 2x. We can even use just table of values, x, y here. Table of values when x is minus 2, y is minus 4, you put minus 2, 2 times this. When x is 0, y is 0. When x is 2, 2 times 2, that's 4. All right, so minus 2, minus 4, you mark, guys, these points as before. So minus 4, just somewhere here. 2 boxes for minus 5 going up, 0, 0. 2 versus 4, we already have this one. 2 versus 4, this one. So you're just going to join those points, and you have got what? You have got your straight line joining the 3 points that we indicated. This was going to be our straight line. So that's the straight line of what? Y is equal to 2x. So you're supposed to draw that. And now we can have the area, because we are told that the area is supposed to be bounded by what? The cubic function, the graph that we had originally. All right. Bounded by that, this one. All right. And the line of y is equal to what? The line of y is equal to 2x, this one. And what else? The line x is equal to 0 and x is equal to 1,5. So we must include these lines. X is equal to 0, which is the y-axis, and x is equal to what? 1,5. So 1,5 in between 1 and 2 on the x-axis, 1,5 is here. So you can see that the area bounded by these graphs, all right, and these lines is going to be in between. So this region in between that one and the what? The cubic function in between here, in between up to what? Up to that 1,5 in between. So you're going to calculate those boxes, all right, the number of boxes that you are given in that interval. How many boxes do we have in that interval? They're going to approximate to 20. There are going to be approximately 20 boxes there. So our area was going to be 20 boxes, number of boxes over 100 times the area of the unit square, 1 times 5, which is what? 5. So that's it. You can just use your calculator. This is 1551. So this was going to be 1 square unit. So that's our area on that region, 1 square unit. Okay. So they do play around something like that. And by drawing a suitable straight line, solve this equation. X cubed, the original graph. Now it is equal to 3x. We are just given y is equal to x cubed and another graph of y is equal to what? 3x. So we have this one. What we need is to draw this one, the suitable straight line, which is y is equal to what? 3x. Just like y is equal to 2x, you use what? Table of values. We saw that for y is equal to what? 2x. Now y is equal to 3x. So simply use what? Table of values. All right. Simply use table of values, x, y here. So I'm just going to insert the x values, 3 values of my choice here, which is, I'm just going to even choose minus 202. So that's minus 2. 3 times minus 2, minus 6. 3 times 0, that's 0. 3 times 2, that's 6. All right, so minus 2 versus minus 6, that's here 2 boxes from minus 5. 1, 2, so this is minus 6. Okay, 0 versus 0, that's the origin. And the other one, 2 versus 6. 2 versus 6, this is 5, and this is 6, 2 boxes going up. So that is it. We can join those points. By joining those points, we are forming what? A straight line passing through the origin. Passing through the origin, join the 3 points that you had. Okay. So this one, guys, I can't readjust. Let me just remove it and redo it like this. Okay. Yes. So this is it. This is our line. So this is our line. So we are going to use that line now to answer our question. This is the line y is equal to 3x, just above y is equal to what? y is equal to 2x. So this is y is equal to 3x. But this one is used for answering what? The solution to solve the equation. Remember, this is simply what? From the point of what? The points of intersection. So you're gonna work with the points of intersection in order for us to have the solutions where the two graphs intersect. All right, the straight line and that one. So it was gonna be approximately here. All right, approximately here. From my graph, it was somewhere at minus 2,7, somewhere here. And the other one on the origin, and here was gonna approximate to 1,7. So those will be your solutions. Negative 1,7 here, 1,5, 6,7. So x is equal to minus 1,7, or x is equal to what? 0 on the origin where they intersect, or x is 1,7. This is 1,5, 1,6, 1,7, 1,8, 1,9. From my graph, like my presentation, I got 1,7. So I'm just going to write 1,7. So this one was supposed to approximate here at 1,7. So it is all that, the smoothness of the graph. You see, guys, those things all they affect. Make sure that the graph is smooth, not glossy, all right? The graph is smooth, not gross. And with that, you can answer any question based on the algebraic graphs, anyone. But when you do not understand, that's the purpose of the community section, the comment section as well. Let us communicate. Let us communicate so that we can have those revisions separately. So like I said, this was supposed to be 2 here. So it's 4, 8, 12. So that's 2, 2. Okay, so that was it. Simple like that. It's all about revision, guys. It's all about revision. So if you do not understand, let's communicate.